Linear inequality applications. In this video, you'll learn that when given a two-variable inequality situation, how to interpret the points in the coordinate plane and decide if they're a solution to the inequality. You'll also learn how to find the solutions to two-variable inequality by using its graph. Let's start by looking at linear inequalities. Linear inequalities can be useful when looking at real-world situations with constraints. When we graph inequalities, the shaded region represents all possible solutions. The boundary line also includes solution if it's solid, but a dashed line will not include the solutions. Let's look at an example. A homeowner is looking for some low-maintenance materials. She is considering turf, which is $15 square foot, and gravel, which is $3 a square foot. She can use any combination of the material, but her budget is $3,000. So let's kind of analyze what this story is telling us. Let's start by labeling our variables. We'll call X gravel, which we know is $3 for a square foot. And we'll let Y represent the turf, which is $15 for a square foot. And we know her budget is $3,000. So if we want to make an inequality to represent this situation, we can write that 3x plus 15y must be less than or equal to the $3,000 in her budget. Here's a graph of this inequality. There's a few points, and then we also see the line that represents the equation. What does the point 500, 100 mean? So we can see this point right here, and it falls exactly on the line. So since it falls directly on the line, that tells us that the cost of 500 feet squared of gravel and 100 feet squared of turf is exactly $3,000. Would 200, 100, or 600, 200 be an option for the budget? Well, we see in our inequality that the symbol we use is less than or equal to. So if we were to shade, it would be below the line. So 200, 100 is in the budget, since it falls in that shaded area. The other coordinate of 600, 200 would be above the budget. Now let's look at another example. A vendor at the Saturday market makes $9 profit on necklaces and $5 profit on bracelets. Give a sample combination of necklaces and bracelets that would give exactly $100 profit. Well, we could take 5 necklaces, which would be a $45 profit, and add 11 bracelets, which would be $55 profit, and if we added those together, it would be exactly $100. Or we can do 10 necklaces, which would give us $90, and 2 bracelets, which would give us $10. So adding those would also give us exactly $100 profit. Now let's give a combination of necklaces and bracelets that would give more than $100 profit. So this might be 6 necklaces, which would be $54, and 11 bracelets, which would be $55. So this would give a total of $109. Or we can take 10 necklaces for $90 and add 4 bracelets for $20, which would put us over at $110. Now let's write an inequality whose solutions are the combinations of necklaces and bracelets she could sell to make more than $100 profit. So we know that we want the profits of the necklaces and bracelets to be more than 100. We can represent the necklaces as 9N, since every necklace produces a $9 profit. And we can represent the bracelets by 5B, since those have a $5 profit. And then we'll set that greater than 100. Now let's graph the inequality we just made. We had 9N plus 5B is greater than 100. We're used to graphing with the variables x and y, so we'll replace our variables just to help us graph. Now we need to get this in slope-intercept form so we can see the y-intercept and the slope. We'll start by subtracting the 9x term from each side. This gives us 5y is greater than negative 9x plus 100. Now we'll divide by that coefficient of 5, and we get y is greater than negative 9/5 x plus 20. So now we can graph this inequality since it's in slope-intercept form. We see that our y-intercept happens at 20. So we'll put our first dot on the y-axis at 20. Our slope is negative 9/5. So we'll go down 9 over 5 and repeat this so we can see a good line. Now let's determine what line to draw. Our symbol is greater than, so that says that it can't equal that line, so we'll draw a dotted line. Now we also need the shading, so the symbol greater than says that we should shade above the line. Based on the graph that we just did, would 3:18.6 be a solution? So we'll graph this point, and we can see that it is in the shaded region, so it is a solution. Let's try another one. The soccer team is selling bags of popcorn for $3 each and lemonade for $2 each. They must make a total of more than $120 to make a profit. Let's write an inequality to represent the number of items sold to make a profit. We'll start by calling X the bags of popcorn, and Y will be the cups of lemonade. Since we know that the bags of popcorn are $3 each, we can represent this as 3X. Lemonade is $2 each, so we'll write this as 2Y. And we know that we must make a total of more than $120 to make a profit, so we'll set this greater than 120. Now let's graph the inequality that we made. First, we'll put it in slope-intercept form. So we'll start by subtracting our x term from both sides. This gives us 2y is greater than negative 3x plus 120. Now we'll divide by our coefficient of y, and we get y is greater than negative 3/2 x plus 60. Now let's graph it since it's in slope-intercept form. Our y-intercept is 60, so we'll put our first dot here. And our slope is negative 3/2. But if we look at our grid, the numbers are a lot bigger than going in increments of 2 and 3, so we want to make our slope a little bigger. So we'll take the slope we're given, and we can multiply the top and bottom by 10, since that won't change the quality of the fraction. This will give us negative 30 over 20. So now this slope will be easier to graph with the grid this big. So we'll go down 30 and over 20, and repeat that so we can see where the line is forming. Our inequality used is greater than, so our line will not contain solutions. So we'll make sure that our line is dotted. And the symbol greater means that we should shade above the line. So now we can see where our solution range is. So any values in this shaded region will produce a profit. For example, the point 1570 would represent 15 bags of popcorn and 70 cups of lemonade would give a profit. Or 30 bags of popcorn and 60 cups of lemonade. Now let's recap what we've learned. Inequalities in two variables can represent constraints in real-life situations. Graphing these solutions can enable us to solve problems. We can find the solutions to a two-variable inequality by looking at the shaded region. Points on the line will also be solutions if the line is solid. A dashed line does not include solutions, though.